In this video we are going to solve balanced binary tree problem from the Leetcode. We will pass pointer to a head and we need to determine whether a binary tree is height balanced. The definition of height balanced binary tree is a binary tree in which depth of two subtrees of every node never differs more than by 1. So the absolute difference between the height of the two subtrees at each node should not be greater than 1. This problem can be solved using a similar technique that we use for finding the height. Let us say we know how to find height of a binary tree. So this problem is very similar to that. If we want to find height of a binary tree, so we will pass that root, and if root is null, we are going to return 0. Otherwise, we will return, since we have a node, it will be incremax of height between the left and the right. So we will return find height of root dot right and find height of root dot left. So this is the logic that find height function, this will return height of a particular tree. We can use this for every node to get height of that particular node. So here we are, instead of directly calling here, what we can do is we can store these values in a variable, because we need this to determine whether our tree is height balanced or not. So our left height will be find height of root dot left, and our right height will be equal to find height of root dot right. Since we have written this as part of this class, we need to use this with self. Then here we are not going to call these things again, we can directly use these things, left height and right height. Now we know that how can we find the height of the binary tree. So anyway we have left height and right height at each node, we can also determine whether this tree is height balanced. What we can do is, in this function we will initialize a private variable named balanced. Initially we are going to set it for true, and then we are going to call this function find self dot find height of root, and finally we are going to return this boolean. So here, while finding the height, we have left height and right height. Here we can check whether absolute of difference, that is left height minus right height, if it is greater than 1, then we will set it to false. Self dot balanced will be set to false, and finally we will return self dot balanced. I hope you understood this solution. The technique is very similar to finding height of a binary tree. Only thing that we are doing here is, in the middle we will compute the left height and right height for every node, and we will check whether the difference is greater than 1, because in the definition they have mentioned that if it is a height balanced binary tree, difference should not be greater than 1. So that is why we are checking this condition, and then we are setting this boolean as false, and finally we will return this boolean. Let us submit this solution and check whether it passes the initial test cases. Yes, As you can see here, this solution is passing the initial test cases. Let us submit this solution. Yes, as you can see here, this solution is passing all the test cases. Thanks for watching this video. If you are interested in learning more about other data structures and algorithm related problems, you can check out other videos from my channel.